Today, I'll solve one fluid mechanics numerical problem on capillarity. Here is the numerical problem. Determine the capillary rise or fall in millimeters in a glass tube of 5 diameter when immersed in a alcohol and mercury. The temperature of liquid is 25 degrees centigrade and the values of the surface tension of alcohol and mercury at 25 degrees centigrade in contact with air are 0.022 Newton per meter and 0.48 Newton per meter respectively. The angle of contact for alcohol is 0 and that for mercury is 140 degree. Assume the density of alcohol at 25 degrees centigrade to be 790 kg per meter cube. Now here two pictures are given. So one picture is capillary rise, another picture is capillary fall. So for this capillary rise, so upward force due to surface tension is equal to weight of the water column in the glass tube. From that, we can easily calculate what will be the H capillary rise. So that is 4 sigma cos theta rho GD. For capillary fall, so we can balance the force. So that is surface tension acting downward direction is equal to hydrostatic force acting upward direction, and that is intensity of the pressure. From that formula, we can also get the same formula, that is H is equal to 4 sigma cos theta rho GD. Based on this formula, we can easily calculate what will be the capillary rise and capillary fall. Now, here is a given data. So data are given here. So first one is the diameter of the tube. So D is 5 So if we convert, so that is 5 into 10 to the power minus 3 meter. Then surface tension of the alcohol, sigma alcohol is 0.022 Newton per meter. Then surface tension of the mercury, sigma mercury, that is 0.48 Newton per meter. Then angle of contact for alcohol, theta alcohol is 0 degree. And angle of contact for mercury, that is theta mercury, is 140 degree. Density of the alcohol, rho alcohol, is 790 kg per meter cube. And acceleration due to gravity, that is g, 9.81 meter per second. Now, capillary rise or fall. So capillary effect is given by, so that we know that is H is equal to 4 sigma cos theta by rho GD. So here sigma is surface tension, theta is angle of contact, rho is density of the liquid, g is the acceleration due to gravity, and d is the diameter of the tube. Now, first capillary effect for alcohol. So now calculation for alcohol. So now we are calculating capillary rise for alcohol. So now data are given. We know that sigma is 0.022 Newton per meter, theta is 0 degree, rho is 790 kg per meter cube, D is 5 into 10 to the power minus 3 meter. So capillary rise for alcohol, H is equal to 4 sigma cos theta by rho GD. So here 4 sigma cos theta rho G and D. So now after doing the calculation, after plugging all these parameter or all this variable value, and then if we calculate H, so H is nothing but 2.27 into 10 to the power minus 3 meter. So that is 2.27 mm. So meter to, if we convert meter to mm, so that is 2.27 mm. So now capillary rise for alcohol is 2.27 mm. Now coming to the capillary effect for mercury. So calculation for mercury given, so sigma 0.48 Newton per meter, theta is 140 degree, rho is 13,600 kg per meter cube, D is, we know, 5 into 10 to the power minus 3 meter, 5 into 10 to the power minus 3 meter. Okay, the capillary depression for mercury or capillary fall for mercury, so H is again 4 sigma cos theta, then rho G T. So here 4, then sigma, then cos theta, cos 140 degree, then uh, density, then G, then D. Since cos 140 degree is nothing but minus 0.766. So now if we and now plugging all this value, and if we do the calculation, okay, and finally H is nothing but minus 2.21 into 10 to the power minus 3 meter. So now if we convert meter to millimeter, so that is minus 2.21 mm. So here minus sign is nothing but the capillary depression or capillary fall. So finally, so final answer or final result, so capillary rise for alcohol H is nothing but 2.27 mm, and capillary depression for the mercury H is nothing but minus 2.21 mm. So that's it for today. Thank you.